Hey, magandang buhay! So for this video, we will discuss all about angles. Okay? So the standard position, the degree measure and radian measure, and the coterminal angles. Okay? So let us start. So let us begin the discussion with definitely the definition of an angle. So let me read the definition. So an angle is formed by rotating a ray about its endpoint. So this definition is not the usual definition that we know in geometry. So this definition is used in trigonometry. Okay. So based on this figure that is being shown on our screen, that is the what do you call this? The best way to describe or to show the definition of an angle. As you can see, we have here the initial side. When we say initial side is the one that is not moving, and the terminal side is the ray that is actually rotating. Okay? So, the figure that you're seeing right now is actually an angle on its standard position. When we say an angle on a standard position, it means that the vertex of the angle is actually on the origin of our Cartesian plane. The initial side of that angle must be on the x-axis. X-axis on the positive side. Okay? And then definitely the terminal side or the ray that is the ray that is rotating. So that is the standard position. Another thing to take note on this one is an angle is a positive. It means that the measurement of that angle is positive if the terminal side rotated counterclockwise. When the angle has a measurement of negative, it means that the terminal side rotated clockwise. So again, if the terminal side rotated counterclockwise, it means that the angle measures positive. Okay, the measurement of that angle is positive. If the terminal side rotated clockwise, therefore, the measurement of that angle is negative. Okay? So, let us proceed. So, radian measure. So, what is radian measure? In trigonometry, we will be more of using the radian measure rather than the degree measure. So, when we say radian measure is the ratio of the length of a circular arc to the radius of the arc. In this discussion, we will be focusing on a unit circle. Okay? So, trigonometry focuses more on the unit circle. So, the reason why we're going to use radian measure simply because of trigo is focusing more on the unit circle. Okay? Circular function to be specific. Now, as you can see here on our screen, this is the illustration of the definition of the radian measure. So, the green one is the angle, and then that red one, okay, the red one is actually the length of the circular arc, and then the blue lines here, that is actually the radius of the circle itself. Okay? Now, let us proceed to what is the relationship between the degree measure and the radian measure. When we are dealing with radian measure, we are measuring angles. While when we were in grade 9, okay, or when we were in elementary, we were taught that when we are measuring angles, we are using degree. So there is actually a conversion from degree measure to radian measure and vice versa. Radian measure to degree measure. So we know that the circumference of a circle is equivalent to 2 pi r, right? Okay. It depends on the radius. But since we are dealing with a unit circle, that is why I only put it here 2 pi, since r is equivalent to 1. Next, we know that one rotation of a circle is equivalent to 360 degrees. Therefore, in a unit circle, we can say that 360 degrees is actually equivalent to 2 pi. So, this will be now the conversion of degree to radian and vice versa, radian to degree. For number 1, let me read. To convert a degree measure to radian, we're just going to multiply that degree measure by pi over 180 degrees. While in number 2, if we want to convert a radian measure to degree, what we're going to do is to multiply that radian measure by 180 over pi. Let me show an example. Before that one, as you can see here, these are the special angles which is being discussed on the next lessons. In standard position, with the indicated terminal sides. The degree and radian measures are also given. Okay? So you may take a screenshot of this one, and then as early as now, you may remember or you may memorize these special angles. Okay? So let us proceed to the examples on how we convert degree measure to radian measure. Okay? And radian measure to degree measure. So let us start with 50 degrees. If we will convert 50 degrees to radian measure, what we're going to do is to multiply 50 degrees by pi over 180 degrees. So if we were going to multiply those two numbers, that would be 5 pi over 18. So the process here is not that complicated. Let us have another example. So we have 235 degrees. Same process. 235 degrees, multiply it by pi over 180. Doing this one, we will have 235 pi over 180, and then doing lowest term, we will obtain 47 pi over 36. Next set of examples will be converting from radian measure to degree measure. Say we have pi over 9. If we're going to convert pi over 9 to degree measure, what we are going to do is to multiply pi over 9 by 180 over pi. Doing this, we will have 20 degrees. So we will get here 180 pi over 9 pi, lowest term, and we will get 20 degrees. So that's the reason how did we get 20 degrees. Last example, we have 2 pi over 5. Same process with the third example. We're going to multiply 2 pi over 5 by 180 over pi. So in this case, if we're going to multiply this and then express the answer in lowest term, then our answer now will be 72 degrees. So again, the process in doing degree to radian or radian to degree is very easy, not complicated. Next one will be coterminal angles. What are coterminal angles? So coterminal angles, these are two angles in standard position that have a common terminal side. Okay? So what do you mean by that one? So it means that the angle in standard position already rotated. It's either it rotated by 360 degrees clockwise or counterclockwise. So with that being said, it means that the two angles are coterminal if and only if their degree measures differ by 360 k. What is k here? K is an integer. Okay? Positive integer to be specific. While similarly, if again z is an integer wherein it's either positive or negative. Okay, so I stand corrected. Z is an integer wherein it is either positive or negative. If it is 0, therefore the angle in standard position did not even move. Okay, so similarly in radian measure, the two angles are coterminal if and only if their radian measures differ by 2 pi k. So 2 pi means 1 rotation. Okay, so k is an element of z, or k is an integer. Okay, positive or negative. So let me show you an example of that one. Ayan. So on the first figure, the measurement of the angle, as you can see there, it's 410 degrees, while on the other one is 50 degrees. On the second figure, that's the standard position. What happened here was that the angle or the terminal side rotated 360 degrees, starting from here, and then it rotated 360 degrees. So it's the terminal side is located on the same position. So that is how we visualize a coterminal angles. Okay. Now let us have two examples that is in relation with coterminal angles. Let us have the first one. So say for example, we have determined the smallest positive angle coterminal with negative 221 degrees. So what we're going to do here is we're just going to keep on adding 360 degrees. Why 360 degrees? Simply because that is one rotation or one revolution. Okay? So we keep on adding 360 degrees until we obtain an answer that is positive. The first number that we will obtain that is positive. So let me show you on how to do that one. So we will start with negative 221 add by 360. We will get negative 100 or 1661. We keep on doing that process until we reach an answer that is positive. So in this case, the answer to this to this task to determine the smallest positive angle coterminal with negative 2,221 degrees is 139 degrees. Last example. So we have the task determine the largest negative angle coterminal with 863 degrees. Same process, but since this is in this task we are identifying the largest negative angle and the given angle here is a positive angle. What we're going to do is we will subtract 360 from it. Okay? So it means that the terminal side will rotate clockwise. So 863, what we're going to do here is we're going to subtract 360 and then we will continue that process until we reach to an answer that is a negative number. So 503 and then we continue the process, we'll get 143 and then continuing that one, we will now attain the answer which is negative 217 degrees. So the topic for the first topic for trigo is not that difficult. It's very simple, very easy. Okay? So with that, maraming salamat sa pagkikinig and magandang buhay.